On through basically where all the orbitals and all this stuff comes from. Then there was a bit, then you should be able to do homework 5. Then I went through the rules on how to fill electrons into orbitals, how to figure out what goes where. Then there was a video within this set of slides that has several examples putting everything together. And then we went through some shortcuts, how you can get everything from the periodic table, and you can already see why the periodic table is arranged the way it is. And after this set of slides, the next set of slides will tie that together to behavior, right? But now we're getting some things that are very useful. And there's a periodic table on every wall in every chemistry class in the world. So you should always be able to have one and be able to use one. So now I'm going to go through configurations of ions and then predicting charges of ions. And that's it on this material. And then you would be able to do homework 6. All right, so we'll go through this, but we're going to go through this, picking up here. This, I think, should be the last video. So ions are formed when electrons are gained or lost. Remember, positive ions, electrons are lost. Negative ions, electrons are gained. If you want to remember it, I don't know if I told you this silly joke, but 2 atoms are walking down the street. One says to the other, hey, you know, I think I lost an electron back there. The first one says, are you sure? The second one says, yeah. I'm positive. So if you lose electrons, you're positive. Just remember, electrons are negatively charged. So that electrons are always gained into the valence or lost from the valence. That's why I wanted to make sure that you understood what the valence is. Remember, the valence is the energy level, not the orbital. It would be the outermost orbital within that energy level, but you know, the 4s and the 4p are the valence. So when you're writing configurations of ions, what you want to do is write the atom first and then the ion. Now, I don't have periodic tables on this set on the slides now, but have one out, or that blank one out, but have one out that maybe doesn't have the configurations on it, but learn how to do this from the table. And there's some shortcuts to figuring out charges that I'll show you in another set of slides later. All right, so we're going to try these. So we'll do oxygen 2-. So first thing we want to do is we want to do oxygen. So again, knowing how to get to here, this is something you should be able to do on your own. So oxygen is 1s. So again, if you need to review the slides to do that, then review the slides. But why is oxygen 1s2, 2s2, 2p4? Now, oxygen 2- means it's gained 2 electrons. They're going to go into the valence. They can't go into the 2s. They'll go into the 2p. So then it will be 1s2, 2s2, 2p6. Or you could write it with the noble gas core, noble gas configuration. So what this means, this is called the oxide ion. We'll get to nomenclature later. But this means O2- and neon are isoelectronic. Isoelectronic means it has the same electron configurations. It does not have the same properties though. Why? Think about that for a second. Why do these two, why are they not the same even though they have the same electron configurations? That's right, this has an oxygen nucleus and neon has a neon nucleus. So oxygen has 8 protons and neon, of course, has 10 protons. So, but they will have, they're not going to have the same properties. All right, try chlorine. First do the configuration of chlorine. Try it on your own. So you should have come up with neon 3s2, 3p5. I've told you it's going to gain 1 electron because it's a -1 charge. It's going to go into the 3p. So it'll be 3s2, 3p6. So if I asked you to write the configuration Cl-, you could write it this way or this way. They would both be correct, but make sure you put it in brackets. Okay? Not too hard, but you want to start with the atom. The negative ions are easier. So the positive ions are a little trickier. So if you want to try them on your own, write the electron configuration first of the atom, the uncharged, and then remove electrons from the valence. Try it on your own. Give you a minute or two. No, just hit pause. Excuse me. All right, hopefully you're back from pause. All right, so let me go through these. So sodium is neon 3s. Again, how did we get this? This is something that we did earlier in these slides, so you want to make sure you review it. All right, we're going to remove an electron from the valence. I'm putting the valence in red just to help you. So it'll be neon. The valence is empty. This would be the configuration of A and A+. All right, for titanium ion, first we do titanium, finding it on the table. Titanium is Ar 4s2, 3d2. Now remember, the valence is where the electrons come out. They are not going to come out of the 3d. And so when I put something like this on the test, you're not going to take them out of the 3D. You're going to take them out of the 4S. Someone's going to make that mistake. So I'm issuing a challenge. Prove me wrong. Hopefully all of you get that right when I put something like this on exam 2. So it loses 2 from the valence, which is the 4S. So you could write it 4S 0, but we usually don't. If you want to write it that way, that's fine, but usually we would just write it like this. Right? Then iron 3 plus. So first we do iron. We did iron before. 4S2, 3D6. Now it's going to lose 3. It's going to take them out of the 4S, but then the third one is going to, then it will come out of the 3D, because once the 4S is empty, the third energy level is the valence. So it'll be loses 3. So it'll be 4S 0, 3D5, or just 3D5. Right? So make sure you can write configurations. Always do the atom first so you can figure it out, and then from the atom, because you need to know what the valence is, and either add electrons or take them out, depending on if it's negative or positive. All right, the last thing we're going to do, and there is a shortcut to this from the table that we'll get to later, but not yet. So we're going to predict charges on ions. So how do we know, for example, that sodium is going to form a +1, or oxygen is going to form a -2? So the bottom line is what's called the Octet Rule. The atoms react to get to the most stable state. Everything falls down. Down is more stable than up. So we lose electrons or gain electrons to become a more stable configuration. Now the most stable configuration is a noble gas configuration. Why? Based on data. Noble gases are extremely unreactive. So that last column on the periodic table, extremely unreactive. So things like to be that way. The reason it's called an octet is, other than helium, they are S2P6 configurations. So 6 and 2 is 8. That's where octet comes from. How do they do it? They either gain or lose electrons. They do whatever's easiest. So if you think of it this way, you want to use an analogy of money. For every electron that you have to gain or lose, you have to pay $1. But if you get to a noble gas configuration, you get paid $4. So you can really look at whatever's easiest. It's always going to do is loses or gains the fewest electrons to get there. So for example, for aluminum, okay, aluminum, you write the configuration. Aluminum is neon 3s2 3p. So the choices would be to lose 3 electrons to get to a neon configuration, pay $3 to get $4, or to fill the 3p, right, go to 3s2 3p6, which would be an argon configuration. That would be gaining 5. So think about this. Would you pay $3 to get 4, or would you pay $5 to get 4? The answer is you would not do this second one. It's going to form the aluminum 3+ ion because it's easier to lose 3 than to gain 5. It's literally that simple. So try these on your own, right, using the same approach. I'm going to count to 5, but you can hit pause. All right, did you try them? All right, so first write the configuration. Magnesium is neon 3s2. So it could either lose 2 electrons, okay, lose or gain, sorry. It could either lose 2 to be a Ne and be an Mg2+, or it could gain 6 and be an Mg -6, because it gets to a neon 3s2 3p6, which is argon. Which one is it going to do? You're right, it's going to do the Mg2+. It will not gain 6, it will lose 2. But this is the why. Like I said, there's a shortcut. Okay, for the chlorine, 3s2 3p5 is its configuration. Okay. So it could either gain or lose. It could empty the valence by losing 7 electrons. It would be a +7. Ugh. Or it could gain 1. Right? I didn't put the arrow, but it could gain 1 here and be in the -1. And that's what it does. It's going to gain 1 electron to fill the valence and be a -1. So chlorine will be Cl-. Right? So like I said, there's a shortcut from the periodic table, and I'll talk about that later on. But for now, this helps you understand the why. And it's important. If you understand why things happen, you can figure out what happens. And that's a real important process in the sciences, is if you understand the first principles, if you understand why things do what they do, you understand charge-charge interactions, you can almost figure out a lot of the other things. I believe this is the last slide. Yes, it is. So that's all the material. That's for homework 6 now. So this covered a lot of homework 5 and homework 6. So you should be good to go through there. There's one more set of slides before exam 2. That's the stuff on the periodic table. Exam 2 goes up through homework 7. right? You feel free to review, and of course I have Zoom sessions if you need to have, if you have any questions.